Alright guys, I'm going to try my hand at explaining what a logarithm is today. So it's really an answer to the question, what is this indice? Now we're all aware what indices are, right? If I have 5 and I raise it to the power of 2, that just means 25, okay? It stands for repeated multiplication. Or I guess if I have 2 to the power of 6, that means I multiplied 2 by itself 6 times. And if you work that out, that'll be 64. Okay, but suppose we ask a question, what is the indice? As in, let's say, we have log 2, not 2, log 5 of 25. Okay, so that basically means what power do I need to raise 5 to get 25? Similarly, this one down here, we would call this log 2 of 64. Okay. So logarithms are just basically indices. Remember, that's what they are. So, this is gonna have a numerical value of 6. And this is gonna have a value of 2. So be aware that anytime you see a logarithm, it's just gonna be an indice, right? So first of all, I guess, why introduce this concept? Like, what's the point? Well, suppose we wanted to multiply two huge numbers. And suppose it was like the late 17th century, so calculators haven't been invented yet. So say we wanted to carry out that multiplication. That's a little tricky. But one day someone called John Napier came along. And he was from Scotland, and he had this bright idea of using logarithms to do the sum. Okay? Because if we take the log of this number, say log base 10, right, and log base 10 of this number, well, what does this mean? I'm just basically asking, if I have 10, what power do I need to raise 10 to get that big number? Okay, and I don't know what that is. I guess it's a bit more than 6. And then same thing here, right? I don't know what that number is, but let's pretend we do. So let's pretend that we find out what those question mark numbers are. Now, the answer, well, we're not really sure what the answer is yet. But the cool thing is we can actually work that out, because if we take these question marks, well, suppose this is question mark 1 and this is question mark 2, then the answer, if I multiply these numbers together, what happens when I multiply two indices? Okay. Well, if I multiply the indices together, I'm actually adding the indices. Okay, and that can be seen down here. Suppose we had 2 cubed multiplied by 2 to the 4. Okay, well, if we work that out numerically, that's going to be 8 times 16. And 8 times 16 is going to give me 128. And that is actually 2 to the 7. So you can see I actually added those indices together. That's one of the first indice laws you learn, that if you multiply, the number gets added. So in other words, if we write this number as a power of 10, we write that number as a power of 10, multiplying becomes just a simple case of adding the indices together. Alright, well, suppose I also wrote the answer as a power of 10. Well, if the answer was a power of 10, then the indice would be this, right? In other words, the sum of those two indices would give me log 10 of that big number. Okay, So what John discovered was, okay, well, let's take the log 10 of the first number and the log 10 of the second number. Whatever my answers are, if I add them together, that would be log 10 of their multiplication. Okay. So then all you have to do is just go 10 to the power of that number to get the answer. Alright? And that's quite interesting, because if we knew what the logs were and we knew how to invert a log really easily, we wouldn't have to do any multiplication at all. So that's quite a tricky concept to explain, so let me give you an example. Okay, let's go over here. Suppose it was log 10 of 1000 plus log 10 of 100. Well, we know how to do this because this is pretty easy, right? This is just 10 to the power of what is 1000. 10 to the power of what is 100. Well, we know in both cases what the answer is. You know, this is 10 to the power of 3. This is 10 to the power of 2. If I add them together, add those indices together, sorry. I'm going to multiply those indices together. Suppose I wanted, on the right hand side, I wanted 100,000. Okay, that's going to work for me because, again, if I multiply these two numbers together, I'm just adding the indice. Okay, so the new indice I want, 10 to the whatever that is, it's going to be the sum of those. It's going to give me my answer. Okay, that's pretty handy for working out logarithms, for working out multiplication of numbers, right? It's a very tricky concept to get your head around at first, but you know, it becomes very, very simple after a while, after you think about it. Right. Suppose we had log 10 of A plus log 10 of B. Well, we've just discovered that this is going to be log 10 of their product. Okay. So that is a log rule that we use for addition. For adding logs, for example, we can now effectively carry out this. And what's that going to give us? Well, that's just going to give us log 10 of 15. Okay, it's an important rule to remember. But just like repeated addition, suppose I had log 5 and log 5 and another log 5. And let's say I want to know what log that is. Well, that's effectively just a log of 5 times 5 times 5. Alright, again, we're going to multiply and not add. So the answer is not 15. It's going to be 125. In other words, 3 log 10 of 5 is going to give me log 10 of 3 to the 5. And that's another rule that's kind of interesting. That means that if I have log 10 of 3 to the 5, I can take that 3 up and down as I please, right? So if you have log 10 of a to the x, that x can just come right in front of the log if I wanted to, okay? But it's important to note that this and this are actually different things. Okay, you see that. Then in this hand, the a is raised to the power of the x. In this hand, the whole log is raised to the power of x. And the rule only works in this case. This case, no. Okay, and we can see why. Really, those are different things. Now, what's interesting is we don't really know, this cannot be simplified, right? If we multiply two logs, unfortunately, we don't really have any rules for simplifying that, so we're just going to have to leave that as it is. But the cool thing is when we add them, again, we can use that rule where it's just going to be log 10 of 12. All right. So those are basically logs. They're kind of interesting. Now, here's a weird point. I've used base 10 for the whole video, and there was no real reason to do that. You know, humans have this strange obsession with the number 10. It's because we have 10 fingers, I guess. But log 10 of 300. Well, what does that mean? That means 10 to the power of what is 300? Well, I could just effectively use log 2 of 300 to get another answer. That would be 2 to the power of something is 300. Right, whatever that something is. Or I could go log 300 of 300. Right, so that's gonna, the question that asks, the indice that represents is 300 to the what is 300. Well, we know one number goes there, right? It's going to be 1. So this log is going to be 1. Interesting. Okay, so let's do a couple of short questions. What's this going to be? Well, you're thinking 3 to the power of what is 81? I'll give you a hint. 9 squared is 81. And 3 squared is 9. So hopefully you should work out that this is 4. That's 3 to the power of 4 is 81. Okay, slightly harder one. Log 2 of a quarter. Okay. If you know your indice rules well enough, you should know 2 to the power of something as a quarter. To get the 1 over sign, we want a minus sign in there. And it's going to be minus 2. Okay. Nice. Right. We can also think about this in a different fashion. Another way of thinking about that log intuitively is going to be log 2 of 2 and then to the minus 2. Okay, and remember we said one of the rules was that this number could come in front. So we can write that in front. And that's effectively equal to minus 2 because this part, of course, is 1. Okay. Yeah. Write x as a logarithm. Okay, well that's just the same as asking log to the base number of 7 is x. Okay, so the crux of this video is for you to remember this relationship and be able to convert with ease. Okay, if you can convert easily between representing something in indice form and in log form, everything else will become simple and intuitive. Remember, this is just an invention by some Scottish dude to make multiplication easier. So what John Napier did is he calculated the log 10 of a lot of numbers and he listed them all in a book, and then he published that book. He actually didn't finish it before he died, but he wasted his whole life pursuing this task. Well, I wouldn't say wasted. It actually helped civilization a huge amount, right? So that's something to read up on. It's very interesting. But for now, I'm going to leave this video here. I'm probably going to do a follow-up one soon, but that's what logs are. So thanks for watching.